video we saw how we can give this function calling ability to the large language model, and we saw the 3pix demo, and we can make a game and we can make it fun. But usually in computer science you are not going to be calling the hunter. We're going to use our existing information systems and connecting function calling against methods, typical methods of our information system. So let's see what we can do. And in this case, what we're going to do is we're going to provide the function wget, which is like connect to the internet, go to the web and fetch contents, and execute SQL. So in this case, execute any SQL, a number of SQL commands like create table or insert or select against SQLite database. So let's see how we do that. We create an array of tools, wget, and execute SQL, and the model in this array of tools can choose the function call that it wants, and these are the implementations of the tools. Let me flag here that if we are going to connect, what we do here, for instance, is a security check. Hey, the model wants to connect to the internet, wants to go, and if you connect to the internet, you can send information out, like for instance, as a parameter in a web call, you can send parameters. So do you really want your LLM to decide that it wants to connect to the internet? And we put here a security check, and the user can deny it or the user can approve it. And we can execute SQL. In this case, we're not going to restrict it because it's going to be an execution locally in a file in our computer, so we will allow it. But here in the tool execution, or before the tool execution, is when we can put some security here. We will talk about later. And now that's our program, a while through loop where we call chat completions, and we send the system with, and we send the LLM the tools. We send it the tools and the messages, just like the task, but we send these tools. And now what we do is use this dispatch method, because if a function call has been called, then we can call the function and execute actually the function in our system. And we will execute just this prompt. This prompt is just go to this URL where we have some JSON and get the information of the JSON and create a table with the information. And let me show you the execution. The execution was a little slow, so I'm just going to show you the results. So LLM call, after the prompt was given, the LLM wanted to do a wget, so go to the URL that we provided in the prompt, and I as a user allowed it, and it executed the prompt and provided a lot of information that it's cut here after this information. And then the model wanted to create the table if it doesn't exist, and the table is created against the structure of the JSON that it received, and then it's going to do an SQL insert into the database. And last but not least, the LLM wants to do a select against the SQL and provides the final answer with the structure of the table that in a properly formatted Markdown format. So what we have here is that by using just a loop and a couple of tools, database access and web access, what we have stumbled into by giving tools, by giving hands, by allowing the LLM to be able to connect to actual information systems by an API, the web API, or by an SQL execution, what we have here is what we call an agent, a ReAct agent.
You have just watched a loop with two tools finish a real task, and Mark has told you what you were really looking at, an agent. Now let's give the pattern its proper name because it has one and it comes from a research paper. It is called ReAct. ReAct stands for Reason plus Act. The paper, Yao and colleagues, published in 2022, proposes a simple cycle. First, a thought. The model reasons about what the task needs next. Then, an action. The model asks for a tool. Then, an observation. The result of that tool comes back into the context. And the cycle repeats: thought, action, observation, until the model decides it can answer. The paper's finding: models that interleave reasoning with acting beat models that only reason, and models that only act. Now map that onto the 6 lines you saw. Line 2 sends the context to the model. The thought happens in there, inside the model. When the response carries tool calls, that is the action. Line 5 runs the tool, and line 6 appends the result. That is the observation, entering the context. The while loop is the repeat, and line 3 is the exit. The day the model answers instead of acting, the cycle is over. You did not implement a paper, you stumbled into it. One honest detail. In our little loop, the thought is invisible. It happens inside the model when it chooses a tool. The original paper made it explicit. The model was prompted to write its reasoning out loud before each action. And today's thinking models, which Mark introduced in Lecture 3.1, bake the same idea into the model itself. The reasoning runs first, wrapped in the interface, and then the action comes. Same cycle, 3 generations of packaging. Why does this pattern win? Grounding. Every thought after the first one gets to see real observations, actual data, actual errors, so the plan corrects itself in flight instead of derailing quietly. That is why ReAct became the engine room of nearly every agent you will meet. Coding agents, research agents, the frameworks with agent in their marketing. Different clothes, same cycle. And you have one in 30 lines of Python in your repository.